Hello and welcome to this podcast. Today I'm going to talk about what will happen in the solar energy industry in the next few years. Before I begin, I would like to introduce a little bit about myself and my experience in this industry. I've worked for a few years as research scientist for some of the largest manufacturers in the industry. My responsibility there was to develop high-efficiency crystalline silicon-based solar cells. I have some thoughts recently on what will happen in the industry in the next few years, particularly in terms of the development of current and new technology. These are just some of my personal opinions based on what I see and experience in the industry in the last few years. First, I think in the next few years, technology-wise, the industry will be driven more by cost reduction rather than high efficiency gain in the devices. Why? More than 90% of the solar modules currently produced are actually made from crystalline silicon wafers. However, the efficiency of these silicon-based devices are actually slowly approaching the theoretical limit these days, which is at about 30%. Unlike 10 years ago, it is becoming harder and harder to increase the efficiency. And not saying that they won't gain anymore, but I suspect that the efficiency gain will be at a slower pace than the cost reduction. Particularly with more and more and larger factories and production lines being set up in countries such as China. Second, if you were following the technology development in solar industry, you may have heard of the materials that's known as perovskite. Perovskite is gaining a lot of attention in the industry because solar devices made from perovskite are able to demonstrate and this impressive gain in the efficiency in just a few years from less than 5% to more than 20%. Plus, perovskite-based solar devices are also much cheaper because they are organic materials and it's easier to be made into solar cells compared to high processing temperature that's needed for silicon-based solar cells. However, one major problem with perovskite solar cells is their instability, especially when exposed to the environment. And it is still a challenge to know how to encapsulate the device to achieve the same stability as the ones shown by the current more mature silicon-based modules. On the other hand, recently actually there are several companies are able to show that their perovskite-based devices are able to satisfy some of the stability standards in the industry. Therefore, I think if these companies are able to continue to optimize and demonstrate an even more stable device, in the next few years, perovskite has a good potential to finally replace crystalline silicon wafers as the main materials to make solar cells. Third, I think building integrated photovoltaics, or BIPV in short, will become more mainstream in the next few years. BIPVs are solar devices that are integrated in the buildings. They replace building materials with a hardware that can generate clean energy from the sun. However, they are currently considered to be very expensive, especially for transparent devices such as solar glasses. But there's actually another type of less transparent BIPV technology that is based primarily on crystalline silicon wafers. They are already very cheap and will continue to drop in price. So I believe that in the next few years, manufacturers, especially those that are currently using crystalline silicon-based technology, will put more efforts and interest to integrate their cheaper device into buildings. Point number 4 that I would like to make today is, I think in the next few years, AI and machine learning will be used more in the industry, particularly in upstream solar PV manufacturing. Machine learning and computer vision have already been used quite extensively currently in downstream solar farms operation, where they are used to detect defects in modules such as hotspot. However, I believe that in the next few years, there will be more awareness among the upstream solar manufacturer about the benefits of machine learning in their production line, especially for quality control, which can help to reduce human bias and manual labels. The fifth point that I would like to discuss today is, I think in the next few years, there will be more interest on third gen or the so-called thin film solar devices. Especially when crystalline silicon based solar cells are approaching their theoretical efficiency, there will be more interest to use other materials such as thin film 3-5 semiconductors to make solar cells on top of silicon wafers in an attempt to boost the efficiency of this device. Thin film silicon may also be deposited directly onto the glass used for solar modules, so that it can save material costs. So to summarize, I've talked about 5 things that I think may happen in the next few years in the solar industry, especially in terms of technology development. The first point is, in the next few years, the industry will be driven more on cost reduction rather than efficiency gain of the devices. Secondly, the perovskite has the potential to replace crystalline silicon wafers as the main materials of solar devices, especially if current manufacturers are able to demonstrate a good stability on perovskite based devices. The third point is BIPV will become more mainstream. And the fourth point is there will be more use of machine learning, AI, and big data in upstream solar manufacturing. And the fifth point is thin film or third generation solar devices will attract more interest to further boost the current silicon-based solar cells beyond their theoretical limit. Alright, that's all for today, and thanks for listening.